Exponential growth example. An entomologist monitoring a grasshopper plague notices that the area affected by the grasshoppers is given by formula a sub n equals 1000 times 2 to the power of 0.2 times n hectares, where n is the number of weeks after the initial observation. So here we have a plague of grasshoppers. Well, they are affecting some area where we want to grow crops or something, and we have to find the original affected area in part A. So let me copy the formula a sub n equals 1000 hectares times 2 to the power of 0.2 times n. So to find the original affected area, the area which corresponds to n equals 0, what I have to do is to substitute 0 to this formula. So a sub 0, the original affected area by the plague, is 1000 times 2 to the power of 0.2 times 0, which is just 1000 times 2 to the power of 0. Since 2 to the power of 0 is just 1, so the answer is 1000. So the answer to that is 1000 hectares. So this is the original affected area. In part B, we are asked to find the affected area after 5 weeks, 10 weeks, 12 weeks, and so on. So n is the number of weeks. So what I have to do in the first subpart of this part is to take n equal to 5 and try to evaluate this number. So the affected area after 5 weeks, it should be 1000 times 2 to the power of 0.2 times 5. Okay, so 0.2 times 5 is just 1. So 1000 times, it's 1000 times 2 to the power of 1. So it's just 2000. Okay, so after 5 weeks we have doubling in the area affected by the plague of grasshoppers. So it's 2000 hectares after 5 weeks. In subpart 2 to part B, we have to do it for 10 weeks. So if n equals 10, then a sub 10 equals 1000 times 2 to the power of 0.2 times 10. Since 0.2 times 10 is 2, we have 1000 times the 2 to the power of 2. Since 2 to the power of 2 is 4, it's 4 times 1000, it's 4000. Okay, so you see that after another 5 weeks, the affected area increased by a factor of 2 again. So first we started with the area of 1000 hectares, then we had, after 5 weeks, we had twice as much, 2000 hectares, and after another 5 weeks we had twice as much, and it's 4000. The subpart 3 of this part B is to find the area, the affected area after 12 weeks, so n equals 12. To do that, I have to evaluate a sub 12, and it should be equal to 1000 times 2 to the power of 0.2 times 12. So if you try to calculate this, you have 2 to the power of 2.4. Let me check it on my calculator. 0.2 times 12, it should be 2.4, yes. So we have 1000 times 2 to the power of 2.4. To evaluate this, I just use the calculator again. So I have 2 to the power of 2.4. I get the answer, which is 5.27, and now I multiply by 1000 and get the answer 5,278 hectares. This is just the approximate answer because the number seems to be irrational, so therefore here I will use this symbol to say that this is just the estimate of the affected area. Okay, in part C we should draw the graph of AN against N. So to do that I will use GeoGebra again. Here it is, and let's add the table view, which is necessary, spreadsheet view, and let me choose the first column, which is the number of weeks, so 1 and so on. Now I should be able to copy it down to some greater value. Well, it doesn't work, it seems. So let me try again. Copy it like this. Yes, it works now. Now let me choose here the formula. So the formula was 1000 times 2 to the power of 0.2 times n. So let me copy it, equals 1000 hectares times 2 raised to the power of 0.2 times n, which is A1. It's the cell A1 there. Okay, so now let me copy it down like this, and here I should have my numbers. So we can check it. After 5 weeks we have 2000 hectares. After 10 weeks we have 4000 hectares of affected area, and after how many there was? 12. After 12 weeks we have 5278 hectares. Now to get the graph again, highlight this, make a selection, create a list of points. So here they are on the left. Now right click on this middle area and zoom to fit. So here are the points of the graph. Now I can include also the exponential function y equals 1000 times, and now we have 2 to the power of, and it's going to be 0.2 times x, like that. Okay, and this is the exponential function of interest to us. So this is the affected area, and again if I zoom out you see that it increases exponentially without restriction. So if you do not do nothing to the grasshoppers, and if they do not run out of resources, then they will increase without limits like that.